So in part B, we're going to be looking at quotients. And so if you take your z values such as z1, z2, again, we have our formula. You can notice this time that we're going to be dividing our r's and subtracting our thetas in order to get our shortened quotient. And again, notice that the moduli are divided and the angles are subtracted. So we've got some how-to to go with it. And you can see that it says, given two complex numbers in polar form, find the quotient. So first thing we're going to do is we're going to divide the radii, or the moduli, and then we're going to find the difference of our thetas, substitute the results into the formula, and replace theta with theta 1 minus theta 2. So to calculate the new trig functions, let's see what we can do with this example. And so I'm looking for z1 divided by z2. And so this is going to be equal to, here's my r over r, so I'm going to say 2 over 4. Cosine of, I'm going to subtract these. So that would be 213 minus 33 plus I of sine of 213 minus 33. So I'm going to reduce my fraction and subtract my angles. That gives me 180 degrees plus I of sine 180 degrees. So I end up with 1/2. Go to my trig circle. Cosine of 180 degrees is -1 plus I times 0. -1 plus 0 just gives me -1, so our final result is just -1. So this one was kind of unique in the fact of it kind of all narrowed down quite to a simple answer than we expected. So I just want to kind of do some quick examples with the quotient. I want to expose you to the powers. And so it says powers is this theorem here, that if z is equal to r cosine theta plus I sine theta as a complex number, then you can raise your r to a power and then multiply that same number times your thetas and get you reduced of r to the n cis n theta, where n is a positive integer, meaning n is a positive integer, so 1, 2, 3, etc., etc. There is more to this chapter, but this is the high points that I want to pull out for you. So I hope this helps. Let me know if you have any issues or questions as you're working through the assignment.